Hello everybody and welcome to this Unity shader graph tutorial. Today we'll be doing something different. Uh, I'll be explaining how we can do the flow map node. In the first part we'll do it as a subgraph, and in the second part we'll be using the Unity shader graph API to convert the subgraph into a custom node. This tutorial will be requiring some knowledge about uh, C# coding as well as shader coding. So I will try to make it as simple as possible. So let's start. So the first thing we will be doing is to understand how the flow map is working at the first stage. So to do that, I'll be showing you a link which is I found in the internet. So how I found this, just went to Google and I typed Unity shader shader then flow map. Okay, and if you go to the first link, you'll be finding this shader example, which is in this part in the fragment shader function. You'll find the flow map code portion, and we will use this code to build our subgraph. So I used to do this. I mean, I used to convert code, shader code, into Unity shader graph to like see how it is working in the previews, and to I can that way I can like change values in real time and see how the effect is shown in the previews. So let's do that and let's see how it works. So to start, let's make a new scene. Let's make a new folder on the our project over here. So like that. Create new folder and let's call it flow map. Okay, so on the flow map, let's create another folder that's called material. Another one for the shader. Okay, this I think it's okay. Space is not there. So another one for the script. Let's call it script. Okay, and as well we will create another folder for the scenes. I used to put S because the folder can have more than one script and shaders, so on. So let's create a new scene, an empty one. That's called flow map. And let's open it. Okay, so here is the our empty scene. We'll just create a quad on into it. We don't need to make any complex object. So we need only to see the flow map effect and to understand it. So this is our quad. Okay, let's change the view. Oh, I think something upside down. Yeah, this is our quad. Then we'll create new material. Create material called flow map as well. Assign to the quad, and we'll select over here shader, custom shader. Outlet one. We'll change it soon as we make our shader, and let's create new shader. So go shader graph and outlet shader. We'll call it flow map. Let's call it flow map tutorial. Okay. So let's bring the game view over here so we can see the changes. Actually, we'll keep it here because we'll be not able to see it. We'll see the preview on the shading graph itself. So let's open it. Here is our preview, and what we are going to do will be converting this part of the code to a shader graph nodes or network, let's say. So let's start doing that. So we'll split this portion of the code into sections. The first section will be getting the flow direction. Second section will be working on the phases. Then the third section will be working on the texture itself, the sampling. Then we'll be working on the let's say the merging on the or the lerp of the flow map section. I'll be explaining all this in details in the next section. So let's start with the first two code. So before we start with that, let me bring the flow map, which is we have already. I'll be sharing all the links and the files within the description below, so you can find them there. So let's create new node, and let's bring first of all the flow map subshade, and let's see what we have in there. So in the subshader, the flow map is getting few parameters, and we have the output. Okay, so the first parameter will be the texture will be that will be animating and making flowing using this flow map directions. So first of all, we'll need a direction to get to the direction from the flow map. So let me save this and open another shader graph, which is we did in the last tutorial, in the molten core CAD bag. So let's open it. Okay. So if you see over here, as we used the flow map to make this waving effect. So as you see here, we get the this plasma texture, and we make it like flowing in this direction using a flow map, which is this one. This both are the same, getting the same texture as a texture 2D asset from the same source. and we did some like tiling and offset modification over this one, and we get the UV of this one, and we pass it to the flow map, so we get this effect. So just a recap on the tutorial. So the flow map will be getting the texture which is will be working on, and UV for the same texture, then a flow map which is the our direction where the let's say the pixels or the fragments are will how it will be animated, I mean, and the direction of it, and then we'll get the flow offset. Okay, this is a modifier on the direction of the flow map, and we'll get the flow speed. The other phase 0 and phase 1 parameters, usually we don't change this. This will be like 1 and 0.5. This is a static parameter, but I put it here for the to check how it is if we change the values, how it will affect the effect. But usually we don't touch that. So let's go back to our shader graph. Okay, so here is the subgraph. If we double click on the subgraph, it will be open the content of it, and it is like a big number of nodes, a network. It looks like complicated, but we'll be explaining it. Actually, we'll be doing it from scratch using the code which is I showed over here. So let's start doing it. Let's close this, and we're doing everything in this shader. So let's delete or let's keep this as a reference over here, and let's start. The first thing, we'll convert this both lines of code to a graph. How we do that? We need to understand how this is working. Okay, so as you understand, this is a shader code. So this text 2D function is simpler to texture. Here we sample the texture, and we multiply it by float 2, and we do -1 as well, -1 float. Okay, so how we do that in the shader graph, we need to sample the texture. So let's create a node. Let's create texture sampler, a normal one. So this is the let's say the flow map texture, which is we can select the texture over here. Let's select any flow map, for example this one. Okay, and then what we did, we did the sample of it. We have the UV of it, so let's create a tiling and offset for this flow map UV. Just like that, we don't need to change any values. We want just to see how it will work later. So let's continue. So we need to like multiply this by 2, and we need to do -1 after the multiplication. So and we will do something else. We will need to flip the red color of this flow map, because in this flow map texture it's not flipped. Normally when you do a flow map, you need to flip the red, or you need to import it as a normal texture. So we'll do that. We'll just create node here, invert, no? Invert color. We'll give it this one, and then we'll invert the red. Okay, then we'll create a node, we'll a multiply node as we saw in the code, So we need to multiply by 2. So we'll create new vector1, let's say parameter. Okay, it's 0 by default, so it will be black. We need to multiply it by 2. Then what we will do will be doing a subtract -1 from it. So let's do it. So we'll add new node as a subtract. Subtract, yeah. I'll give it this one, and then we'll do. Now let's duplicate this. Okay, and do 1. Okay, here what we have. So we have done this line. So the result of this line is the flow direction, let's say, which is this result, this and line result. So let's move forward and see what we have next. Then the next thing we have multiplied this flow direction with the flow speed, but here he is calling it flow speed, but I'll change it as offset, because we'll be using this as flow speed. So let's do that. We'll create another multiply node. And we'll multiply this by another parameter, which is the vector1. Actually, we will create it as a parameter over here. Let's create flow offset. Okay, this is vector1. We'll give it as a default value as 1. Okay, so it's multiplied by 1. Nothing difference, it should be, because it's 1. And after that, we'll prepare the phases, right? So phases are the part where we take care of the animation. Because if you see over here, we have the time, and we have an offset over here by 0.5 as a float number, and that way we build phase 0 and phase 1. Okay, so let's try to make it in the shader graph, and I'll explain what is the phase, what are the phases. Okay, so let's go there, and we'll go here and take the time node. Okay, then as we have the time like this one, and then we have to multiply it by let's say flow speed. So we need to multiply node. Here is our multiply, and we need a parameter, another parameter, a vector1 parameter, which is we call flow speed. We'll give it 0.2 by default, and we'll assign it to the multiply. Okay, then let's go back to the code, and then and the first the phase 0 will add to it plus 0.5. Great, add node. This will type it over here directly, because it is will not need to change this as a parameter, so it is a constant 0.5. Okay, we need another add node to build the phase 1. So here it is. Here will be 1, and we'll add it to the result of the multiply. Okay, and we'll need the fraction of the both result, which is this function, which is the frac. And we have this a node which is will do the job for us. So it is frac fraction. Let's see. Here is the fraction. Duplicate this. Okay, we start seeing the animation over the preview of the fraction. Okay, so this one is the result of the phase 0. This is the result of the phase 1, as we have over here. Phase 0 and phase 1. Now we'll be working on the texture sampling. So we'll need both, I mean, the same texture as we gonna sample it 2 times using different phase on the UV, which is multiplied by the flow direction and added to the original UV of the texture. So let's do that. So create new node as simpler 2D. Okay, click over here and duplicate this. Okay, and we'll select the texture, which is we'll use it on the flow map. So let's see, let's select any one. I'll just delete this and duplicate this, so I don't need to select the texture again. Okay, so we have the both sampling over here. After that, as we see in the code, we have the sampling, the texture sampling over here, and we have some let's say instruction over the UV, which is we'll do right now. So what we did, we take the original UVs and we'll be adding this flow D multiplied by the phase. So let's do that. We'll need to tiling and offset node. Let's move this forward. So here is the tiling and offset, and we need to add this to the flow direction multiplied by the phases. So we'll get an add node over here. So this one, let's move this again forward. This as well, to the top, and we need to add this to the product of the flow direction by each phase separately. So create multiply node. Multiply this by the phase 0. Duplicate this and multiply it by the phase 1. Okay, so as you see, it's not animating in the same time as we did the offset over here 0, 5 and 1, and then we'll be adding this and this to the original UVs. So we'll be in another add. Let's duplicate this. Let's give the original UV to it, and let's link the different phases. Okay, so the result is the UVs, and then we'll assign the UVs to each, let's say, texture sampling, and we start see the flowing over here. Okay, then we are done with the texture sampling part. Now we'll be dealing with the let's say the last part, which is the lerp and the value of the lerp. We'll be need to do a lerp between the phase 0 simple texture and the phase 1 simple texture, and we'll define this lerp value. To define this lerp value, we'll need to implement this code section into our shader graph. So let's see how we can do that. So the first thing we will be doing will be getting the phase 0, which is over here, the value of it, and subtract 0.5 from it, and let's do that. So we need to get the result of the phase 0, which is this one. This is the result of the phase 0, and we said we'll add a subtract node. Okay, actually we'll be needing to put it in the second on the B, and we need to put 0.5 over here. So we subtract 0.5 minus the phase 0, and then so we did implement this section, and then we need to divide it by 0.5. Okay, so we need division, we'll divide this by 0.5. Okay, and we will be getting we'll need the absolute of the full instruction. So as well, we have the absolute node. Here is the absolute result. Okay, so as you see, it's like going from 0 to 1, then go back 0 to 1. Okay, then we need in the last line of the code, we need to do lerp on that value. So let's get lerp node. This is A, this is B, and here is the value of the lerp. Okay, and let's connect it to the result. Actually, we step too much forward, so let's bring those our reference and the output node here, and let's link it, and let's see what we have. Let's change this to quad. Okay, so as you see over here, the flow map job, let's say, it's to get the texture, the main texture, which is we get over here, and to make it like animated on the flow map, which is we provided over here. and it should be looking like flowing in continuous way, which if we didn't do this part of the code, we'll see like there is let's say a cut between the flowing, which is you can see it if you just link this directly to output. So as you see over here, there is an animation, then a cut and restart. Same thing, you will see it if you put the phase, let's say the phase 1. So as you see over here, the same thing. But if you remember, we did a difference of the offset between those phases, which is in here, 0, 5 and 0, 1, and we did lerp between both using this lerp value to remove the this animation, let's say restart. Okay, so if you link it back, you'll see the merge between those both faces, and it will be looking like it is continuously animated. So this is the flow map, how it is working. Okay, so we did the implementation of the full code, which is over here till this final color, and we did it like shader graph. And you can after you finish with the implementation of the code, you can like select all the nodes and convert it to subgraph. Then you will need to implement the parameters, and you will have the same subgraph as I did over here. This is the same thing actually. Okay, so we are done now with the implementing the flow map as a subgraph, let's say as a shader graph in Unity. And the next part will be converting, or let's say making a custom node, not a subgraph, using Unity shader graph API. And we'll take this code and we'll make our new node. So I'm using the if you see over here, we have the shader graph API. If you go back to the editor, then you go to the data, you'll see the definition of the nodes, all the nodes over here. And if you go, for example, let's say math, and let's say basic, and let's see the add node, and we'll be implementing something like this node. We'll understand how it is done, and we'll do a similar node for our flow map. We'll do that because you need to optimize your shader graph. If you need to make, I mean, in one shader to make to use the flow map many times, this if you use the subgraph, it will be too much code. Let's see, let's give an example. Let's save this. Okay, let's open for example one of the tutorials we did with. So this is shader graph we did in one of our tutorials. As you see, it's loading a little bit slow on the loading. And if you see over here, there's too many things. Let's search for the flow map we used over here. Okay, here is one. This is one flow map, subgraph actually. It is a subgraph. And another one, I think we used it the second time. This is not a flow map. Yeah, in here we use it the second time. So if you use it too many times, as it is, let's say, having a lot of nodes, it will be too much code. You can see that if you right click on any node and copy the shader code, and you go to any text editor and paste it, and you see over here that we use the flow map many times. This is a flow map call of the subshader, and if you see in the flow map subshader function, let's say, you will see a lot of code, which is the subshader we did. But you don't need to do that. If you want to optimize your code, you need to implement this subshader as a node using the Unity shader graph API, and it will be like a portion of code like this one. So you don't need to type all of that. You don't need to use the subgraph anymore and generate that number of lines of code, and it will be not optimized. So the next tutorial will be doing that, and see you on the next part.